Are you good?
I'm good.
Nice. Oh, wow. I didn't touch anything.
We believe you.
Hi, today I'm going to talk about some work I've been doing for creating agents. It's more like in the cloud, and like it's very much related to platform engineering, because I feel this is where the industry is going. So it's kind of like I see where the task that I have to do, and I feel like soon everybody is going to be doing like more or less the same. So it's more like a preview of what's coming. Yeah, it is. No, I'll try to cheer you up, you know. But hi, I'm Julien. I'm part of the Google Developer Expert. If you want the slide for the links, they are on the website. So first, to explain, you know, agent. I saw this story on Twitter. I could not find it because who can find anything on Twitter? But like, this is more a woman sent that to her man, and she said, "Honey, can you buy sausage for tonight?" And she put the little heart emoji. Do you know how many sausage he bought? Oh. 2. He bought 2. That's how it feels to talk to an agent. That's exactly how it feels to talk to an agent. And it's funny because it's not like, you know, we talk a lot about intelligence, but everybody's wondering what is intelligence. But you talk about stupidity, everybody knows what it is, right? And that's kind of like what we're going to talk today. So, life of a prompt. Do you know what happened when you type something and you press enter? Well, if you do that, it's kind of like there's a lot of things under the hood, and not all of them are like super advanced. I try to go like high level, but in the end, you're gonna understand why those things are not like they don't have a soul. And it's kind of like, I read somewhere that, you know, when you die, you know, you don't feel anything, but it's painful for others. And apparently when you're stupid, it's the same. So, and you know, it's really painful for others. So those they don't feel anything, but they make life of everyone else completely unbearable, because, you know, if you have an open source project on GitHub and you have to go through those PR, and it's like, this is chaos, you know, this is really chaos. So what happened? First, some vocabulary. We're talking a lot about model and harnessed and, you know, AI, but they talk about agent, and like, what is an agent? And they say it's the harnessed with the plus the model. And it's like, well, what's the harnessed? And it's like, well, if it's not the model, it's the harnessed. That's how they define it. They explain it much better. But so harness is basically everything that's not the model. So everything around. The UI, you know, the interface, the skills, whatever. Like, all of that is harness. And this is the high-level step that I'm going to go through. So first, you send a request. You have a chat template that converts that request. Then you tokenize, you prefill, you decode, and then the response comes back and you unwrap it. Like, that's what happened. So first step, it's very simple. Like, this is what you type, what is artificial intelligence? And the harness wrap that into a JSON payload depending on the API. You have the OpenAI, you have Anthropic. Like, there's 2, 3 type of, like, typical, you know, we all know how to make a request, right? It's JSON over HTTPS, nothing crazy. The shape is interesting though, because like, you have some parameter that you can tune. You have the message, and you have a role and a content. The role is actually has also bare meanings. So if you want to see what happened once the server receives your request, it's not like it just take the text and give it to the model. It has to use what is called a chat template, and it's per model. So Gemini and you know, the Gemma 4, Qwen, everything, they all have a different chat template, and you can see them in, of course, 1 second, I have to click the link. This was really not practical. Oh. But so this is the chat template. It's a Jinja template. So we know it's like, you have some rules. This is really big. Ah, thank you. But you see, like, for instance, you have some tool here, and you have those weird tokens, like, where are they? Like those things here. You see, it's between bracket. That's from what I understand. Again, not an expert. Like I discovered this stuff last year, and it's like I'm learning. So feel free to tell me if I'm wrong. But this is what we call a marker, and that's really important. There's different type of marker. So for instance, when you do auto-completion, is the FIM, F-I-M, fill in the middle, that you need to put at a certain space, and the model knows that that's where it needs to fill in. But if you have, like the chat, it's usually at the end, and it's like turn model, or turn, like, and then he knows he has to predict the rest. And of course, if you try to change this model and try to tweak it, it completely breaks down. They're not smart at all. You understand? Like, there is no intelligence whatsoever. It's really just a template that if you respect some markers, then it generates something that has meaning to you. It doesn't understand thing.
My method of just naming all my variables into various types of curse words, it doesn't work anymore with this.
You can try. Like, I haven't tried though. You know what? It's the kind of things that the more something looks stupid.
It ought to work.
Yeah, but I'm gonna say something. I'm gonna say something I'm gonna regret. Let's carry on. Let's carry on. Yeah, tokenization. So this is where you take this chat template, you fill in the request, you get something that's kind of like that convert that to tokens, and those tokens, they're actually numbers. I'm gonna try and see if I can. So, oh boy, that's. So I made a little demo to show what is a token. So you can select a model, and for each model you're gonna have different tokens. This is the system prompt. Like, this is what appears at the beginning. It defines the instruction. Every model supports one. Then you have what the user request is. This is what is the result of the templating. So I'm sorry, it's a little bit small, but maybe.
We can see it.
Like, you see, you have those weird templates. If I take Gemma 4, you see it starts with a boss, and actually they are here. So it turns this actually represents numbers, tokens, and those specific tokens, these are the marker in yellow. In between is those tokens. And so when you change something, for instance, Eli 5, you tokenize, and you see Eli is 17,515, 17, and like each of those tokens represent a number that means something based on the set the model has been trained on. Do you know what Eli 5 means? Yeah, exactly. And that's a quick way. Like, I didn't know that, but someone. Sorry? Yeah, exactly. Ready. But and so the craziest thing is that it knows exactly what it is, because it has been trained on so much data from the data set. So now we are the text into token. Then we come to the prefill. That's where you take those tokens and it creates embeddings. What's an embeddings? It's a long array of numbers that is usually represented by weight. Is the number that the weight will be multiplied on, from what I understand. So if you have like 5 billion parameters, you're gonna have 5 billion of those, kind of, from what I understand. So there, you convert the tokens into vectors. That's what they call embeddings. And then you have the computing the attention. That's the whole value proposition of those models. It computes the attention, and what it means is that it do matrix multiplication to know the relation of every word to every other word. So in my sentence here, where is it? There. Like all those words have a relation. And you know, because what is intelligent artificial question mark? You know that the question mark is related to the what strongly, and then artificial intelligence. And so you have this kind of numbers that represent relation between each word. And that's called the prefill. And that's very compute bound. So on the GPU, it can do everything, calculate all those relationship in parallel. That's why it's very compute bound. And as soon as that phase is finished, it gives you the KV cache. Because those numbers don't need to be recalculated every time. So you just store that, and they call it the key value cache. That's going to be passed for the next phase. This is the time to first token, TTTF, TTFT, sorry. Okay, so now the step 5 is the decoding. This is the only, I'm almost done, you know, it's like, it's not gonna be as complicated as that. But you get this KV cache, which is basically the matrix of all the relationship from all those numbers. And the algorithm is kind of like, it's not that complicated, but there is just a few pieces. It takes that, and it computes the next token based on the last token it received. Does that make sense? So you see my question, what is intelligence artificial question mark? You see the question mark, and it predicts the token after the question mark. And that's how it works. Like, that's it. It's statistics. It's not like magic. It's based on the weight of the model. The better the training, the better the answer. It's also like how the model has been trained and how much, you know, parameters it can handle and everything. And that's the token per second that you see. This is memory bound because it can only predict one token at a time. And so it predicts this one, then you say, what's the next token for this one, and then this one. And so that's why it has to go and reach and see all those statistics everywhere. So that's memory bound. The prefill is compute bound because it has to calculate all those relationships. And that's AI, you know, like that's what they all talk about. I really like made a mess of the explanation, but that's how I understand it.
And now they broke it with multi-token predictions.
Yeah, that's actually pretty smart, you know. It's like because the prefill is quadratic, so for every, you know, if you double the size of your context that you send, it means you have 4 times the amount of compute that gets done. So imagine sending a few megabytes of text and just like, it's an explosion of things, and that's
also
why.
Known as the Claude prompt.
Yeah, true. It's like a 10,000 token just on, you know, say hi, 10,000 tokens. Just so, and that's what I'm going to talk about here today is really the agent. When you have to build this harness, this is the kind of stuff you want to know and pay attention to. There's also a specific type of parameter that's really interesting is called the chain of thought. So instead of, it's also predicting the next token, but it doesn't try to answer it, kind of. It just try to fill in the blank of what the user says. You know, so it's like, okay, what is artificial intelligence? It's like, explain to me like I'm 5 because I need to know and you have to explain this. And so it generates its own token and then trying to answer the question. So that's what thinking is. It's still decoding, it's still you paying for memory, and it generates way more token. And it has to recompute in the prefill all those tokens. And I'm going to show you that sometimes it's good to shut off thinking. But that's the thing, you know, like you see the thinking of some model, and that's where it's coming from. There is 3 flavors. I'm not going to go around, but basically, you know, you can choose the effort in some model. That's what it is. It's like, how long should you have to keep going generating those thinking tokens before you switch to the mode of answering or like changing the turn. And that's why at the beginning I showed the role. First you have the user. This is the system role. So they split it into different categories like that so that the model know it's kind of steering it into the direction that you want. yeah, you have, of course, a lot of trade-off, you know. Don't expect it to be cheap. And I find that sometimes the training has been good enough for like 80% of the task. Like if you just want to write a file, if you just want to do something, if you're not designing something or you know exactly what you want, you can easily turn it off. That's a big saving. And the reason is that like if building an agent is, well, is building a tool for someone else to use and you don't control everything that's going there. So that's the kind of things like if you want repeatability, you can turn off the temperature to 0. And so every token that you predict, given the same input, will be the same output. So that's also you have probably 20 knobs that you can tune, and you have to understand what they mean and what they do. It also requires a lot of A/B testing, and you burn token when you're doing that. So sometimes it's just like more is not better. That's what. And the response, because it generates one token at a time, it's one, payload per token, and then you see it appear in your, on your screen, and that's really the request. So from the moment you type to the moment you start receiving answer, you cannot understand where those knobs can be tuned or not, and that's it,
This is going to be super important in the next 2 years now that we're running out of memory.
Yeah.
Before everything just had the same amount of memory and the same speed. In the next couple of years you will have really small but fast SRAM memories, and then you will have the big things for it, the mixture of experts.
Yeah.
Knowing the context and what you're doing with them, you're able to run it on the right memory with the right speed, and it's like a 10x improvement if you do it.
Yeah.
Right, and a 100x disprovement if you do it wrong.
Yeah, sometimes I don't remember where, but I've seen that you can tune how many expert in a mixture of expert model you load, and more is not always better because it means that he has to go through all those models, and sometimes he just picked the wrong one, or like it's not the one that you expect. So more is not better. That's the thank you for the. Now, when it comes to tool calling, it's a special marker that you get, and it returns, and it's like, okay, this is for the harness. Usually those are in JSON, and you would be surprised how many times they give you bad JSON, because it's like random, you just generate. And then suddenly you have like a parsing error, and you kind of have to deal, like, how does your harness handle that? Do you try to correct it? Do you still, or do you just send it back and say, hey, just give me correct JSON? For small model, I mean, you can try to correct it. And also the way you use those markers really is important. With the chat template. I tried to mess with it. I had none of it that works. I'm not smart enough for that. So. But yeah, that's a tool. For instance, here I have like list BigQuery tables. Usually, if you build an agent, you kind of want to give it some data. You want, if you're building something for dashboard, yeah, you have to restrict somehow. And this is kind of like the schema that you expect. It's different from every API, to be honest. Like, so, your mileage may vary. But the way it knows which tools to pick, like for instance, MCP or those kind of things, you have a description of the tool. Those needs to be loaded, usually in the system prompt, but the system prompt is really at the top of your conversation. And so the more you go down, the further away the relationship of that is. So, that's why you start forgetting stuff after, a few 100,000 tokens. It's just like, it's too far away. So there is and this is more like prompt engineering. I put the links to the paper. It's like 80 pages. It's kind of like really interesting. It's a bit dense, but I wouldn't recommend to read it in one go. Like.
And don't show it to your security people.
Yeah, what security? It's in these things. I'm going to talk about it. Don't worry. Like, but this is what it kind of look like. The user say how many events yesterday. you have the tool use that has correctly been, as, I don't know, it's not called, but like picked up by the model, it send you, okay, you should call this tool if you want that. Then you get the result. From the result, you have to send that back to the model. It says, okay, this is not the last information that I need. You need to query another table. And that's where it keeps on poking stuff. And if somewhere it fails, like you have to decide what to do. And that's why this tool calling, the whole point of agent is to call external thing and get access to data. And that's why tool calling is basically 90% of the work, which tool, how, when. And that's what the harness does. You're just like working on that probably the majority of the time. You might want to put guardrails, and suddenly, it's like 10 years ago, everybody was building their own platform on top of the cloud to restrict developer from not messing up. Now we're doing that with agent. So the job here is just a function that prevents anything that's not a select. So you can only get data. You cannot modify the data. You cannot change. You cannot delete. You cannot do anything. You might also want to put like some kind of limit or like put a cost to it so that the model doesn't start, querying, oh, let's see how, for the last 10 years, what kind of event, and suddenly the bill explodes. So the way I try to put it, it's per tool you have to secure this. So the work is like, it's kind of hard. But imagine that you have somebody that drive, 1,000 kilometers an hour, and you have to build those guardrails there. And you don't know where it's going to go, but you have to help him get to his destination. So that's kind of the job. It's really like, whoa, and then you have to, a drunk driver, with a super fast car. That's not easy at all. And yeah, so when the tool call fail, you can decide whether to send it back with the information. It's like, hey, this fails. Here is why. Here is the, whatever debugging information, because this is runtime information. The result of that is actually quite useful because you can do statistics on it after to see if you need to tune the tool calling. What happens when you have too many tools, But basically it gets drowned. It doesn't find it. It doesn't know which one, called the wrong one with the wrong, parameter and everything. And so the fix was actually Cloudflare. They find a kind of like a workaround. It's like you can only have one tool, and that's tool search, So, but that also means you have to do, two back and forth with the model, because first he has to list the tool, you give it a list, then he has to decide which one, tell you to call it, and then you call that one. It's a bit of, like, there is no good, scenario. It's all a trade-off. This is one of them. It's, I haven't found any good solution for that. But it's a very dynamic, It's like certain things can work, the other, you might not. Although there's two things that's helpful to measure to see if your agent is actually working correctly, and it's called helpfulness and harmfulness. Mm-hmm. It's a paper released last month by Apple, and I found that it was, because you don't know, like, what does good look like? It's like, if I know, do you think I would be building this? So it's kind of like not really, it's not the point. Like the point is like the percentage of errors that the agent, where it corrected successfully. So you have a wrong one, then the next one he fixed it. Like that's one, and the opposite is true, It's like he got the right one, but the second call he failed. And like, why? And so you can see a little bit about those things, and it helps you understand and tune the tooling. I haven't gone really far with that, but this is the Cloudflare blog, because the API is like 1,300 tools. No model can fit that, and so they let the model write the code to call the tool and send it back, which is You know, they work with sandboxes and everything is kind of secure. But if you do that on your, you know, production database, you know, be careful. And that's it. That's kind of the architecture. You have the client that call the harness, which is like the backend. The backend has access to the LLM. It has some database because you need to store those conversations and, you know, the logs and everything, the access log. And then you have tools, whether it's data or bucket or database. I would highly recommend, if you're interested in tool calling, actually the Llama CPP documentation. It's in the repo. There is no website or anything, but there are like a few, you know, really good tricks in there because it's very much like empirical based. You know, they tried, they see what works. It's like, hey, you know, you might want to try this or that, and it was very helpful. Security, that's where, and I find that is actually there is no point in trying to tell it what to do. Like, for instance, if you have to build, you have developers, they come to you for your platform, it's easier to actually build a good examples that is deployable and say, hey, don't ask me, point your clankers to that repo and ask what you need. That was amazing. I would say like this is like cross languages. I built it in Go, the app was in Python, and at the end we had like a super secure or secured enough, you know, with OAuth and like no token, no credentials was stored and everything. And that because the model has a good example to based on. It doesn't matter the language. You can just work on, you know, the most common language if you're going with something like Haskell or, yes?
Sorry, but I need to ask here, when you were building that good example, were you heavily on using libraries or that secure logic was right there in your code?
I don't understand the question.
So, for example,
it was not meant to be reused.
I understand, but I mean, I'm really curious to know how far did the model go? So, for example, you did demonstrate how you're going to use authentication and authorization, for example. So, did you use some logic there to generate the GWT tokens and sign them, or did you use some
library
or existing, you know?
Yeah. Like I usually use the Google libraries because I'm on Google Cloud, and so that I've built it before.
A very known library.
Yeah.
And
That's
then he was able to deduce the good practices out of that.
probably. I didn't write the Python app, so I don't know. All I know is that I saw the result, and that was like perfect. You know,
Okay, that's an open repo.
Yeah. That I built it. It's like it's very Google Cloud. But basically, it's like, what is your use case? Do you want to give that access to only internal people or external people? Like, and also it used the OAuth token so that you can pass that. Like, for instance, if you have an employee or a developer that has access to some database, well, you don't need to configure that in the application. You can just use his token to access the database. So you just forward the credentials like that, and that was very seamless. All the authentication and everything, the audit, and like everything was kind of embedded because it's also the cloud, so there's a lot of stuff that was coming there.
You were basically stealing the structure of that repo in a way.
That's my repo, I wrote it.
Exactly.
Yeah. I tell him like steal that. Yeah, just based on that, I know this work. I know I can vouch for that, and
if it doesn't, it's my fault. So.
Yeah, kind of. Yeah. You know, everything in platform is like, you get no thanks, but something goes wrong, they know to God.
But I still think you can write a secure example like that and still LLM won't like capture all the Go practices.
Oh, yeah.
In there. That's
But
what I'm saying.
The way I build it was very much like half an example. Like this app doesn't do anything, but you can deploy it, and there is like a little box that say who you are, and like the typical tutorial example, and that was just brilliant. I mean, perfect. Also, Python is a very well-known language, so I guess there is that. I don't know how it would do for something like TypeScript. I haven't.
Things like Java and other stuff.
Yeah, I think it's.
Anyway, okay, thank you.
That's a heavy topic, like compaction. So you're gonna have all those conversations, So you have, you know, people start using your agent and they start talking to it. And then, you know, the context is a limit. So you have to compact, and there you have to make decision. Like, what do you do? Because, you know, the more you speak, the more the context fill, and the more you're paying for the hardware. So I'm going to go over pretty short, but what I find is this. After 100,000, 150,000 token, you can see directly the quality of the response degrading. So 150 token is not that much. Most context windows don't go, you know, even that far. But if you use the frontier model and they claim like 1 million token, it's like, yeah, maybe if you don't do something very like design heavy, you know, it's just like, hey, move this here, do that, like so some short, easily doable task. But if you have, even though that, if you're managing the agent, you're going to reach a certain limit at some point, and then you have to decide, well, what do I keep, basically? And that's the whole point of compaction. It's on a threshold, so you have to decide where is the threshold that you want, and you need to leave a little bit more. You cannot wait until it's the end and it's completely full, you know, because then you have no space to actually ask questions to the model. You have to do something else.
I think bloat keeps 30,000 tokens for all the compaction bug.
How many?
30,000.
30,000? That's the system prompt, like.
So that's the buffer for all the compaction.
30,000 for that, for compact. Oh yeah, okay. That's pretty good. And the reason is 30,000 is because they inject 30.
System prompt is 23,000.
Yeah. Really?
Yeah.
Which model? Anyway, we can check that later. I got Nerd's Night here. Like, but yeah. So the reason you need is because you need to give a prompt, an extra prompt saying, hey, you know, compact this. And the way you can ask is either, well, keep the tool calling or not. Like you probably need to keep some IDs if you touch some file, you know, if you access some data, some row, or if you ask question. And those things get really, really complicated really fast when you try to make decision and be super generic about it. So I guess that's why they need like 30,000, which sounds like insane, but I can understand. It's very clear that you can reach that pretty far. And I find like 3 strategy to compact. You have the sliding window, so that means that the oldest gets truncated, like you just drop them, who cares, and you're just moving. This is perfect when you have someone who doesn't care and just keep reusing his same window and he just doesn't understand. Otherwise, you have the summary, just at the end, summarize me this, and you replace the whole conversation with that summary. But if you're doing too many things, you might want to try the hierarchical, which is summary of summary. So you chunk the conversation into separate part, and then you summarize that part.
So checkpoints, basically.
Yeah, exactly. Yeah, you can do that. Honestly.
How many steps would you divide up those 150,000? Or is it 10 steps?
No,
15, or is it just a one shot, 150,000 tokens?
The 150,000 token is more like, it's my understanding of, like you have that much of good thinking model. Sorry? Yeah, exactly. So you have about that. So if you do many tool calls, you're just wasting valuable, like it's the prime token, like those are the really good one that will help you find the needle in the haystack. Whereas when you're above like 300,000, just like, roll the dice and see what you get and don't expect too much. But yeah, so this is an example of summary prompt. It's very basic. I wouldn't ship that, but it needed to fit on the slide. And it's basically like, yeah, you just preserve the user original goal, the decision you already made, try to, what would be a good summary of a conversation, which is something I never had to think about. But actually, if you had to summarize things for, school or stuff, this is where actually it becomes really useful. Yeah, so tool calls, they actually take a lot of context. Like if you list files, if you list, even tables in the database, if you want a schema, those things take a huge amount of token, and each one of them, takes space, and you cannot always like choose what to keep. So is it better to just, what do? You drop them and make sure to call them in the compaction so that you can inject and have some, to be sure. I don't have a good answer to this. Like, it's really complicated. It's trial and error, and honestly, I wish I had better news to give for you. But yeah, and actually, if you look into the repo, all your conversation, if you use Cloud Code or Codex or Gemini, all your conversation are stored on disk. And I went and poked to there, and that's how I learned about the turn and everything, because I could not really understand what it is. And you see how they handle things. It's usually when I have a question, I go look, what kind of things they did. So I can search into my conversation and see, okay, this is actually, the tool call. When I see how much token they send, it's like crazy. So now I'm running bare, It's like nothing. I have no MCP, no tools, like nothing. I just activate on when I decide to. Also, what I find is that you can branch conversation. So you can start something, have a good question, and like spend some time. It loads all that into the context, and then you can branch and have different conversations. Sometimes it's really useful, or if you have a side quest, you see, I want to debug this. You can branch the conversation, do your thing, and then come back at the point of the context and continue to another branch. It's a lot of, management and things, but you can do it. The problem is it's really hard to do it automatically. But that's basically what sub-agent does. A sub-agent is take your conversation, or you take a prompt, it goes somewhere, and then it gives you the result that you inject into the context, and it continues with that. And it keeps iterating. So what I mean is like there's no magic here. It's all like trade-offs and little details here and there. If you want, I found this, and I think it's so good. Honest agent disclosure. You can use that as a system prompt. And it basically, like, you have a stateless text prediction process. Instead of, you are a helpful assistant. It knows it's a helpful assistant. It has been trained for only being a helpful assistant. So you don't need all that fluff. It's like, why are you saying I? You're a robot. Don't bother me with this. Just give me the fact, And I found it was quite interesting. The problem is, it's freaking long. So I would say, like, you can use that, ask your model to strip out what you don't need, have a really nimble and focused system prompt that you can use for your agent. And that's like, this is how you get, good result. Sorry?
You should use PyAgent.
I use PyAgent.
Yeah, that's amazing.
Yes, it's also, you can tune it the way you want for your use case, which is kind of,
no MCP.
Yeah, no MCP, no nothing. And that's kind of the point. Currently, we are in a subsidized phase where your $200 a month subscription is actually, it's a good reduction in the real price. Like, I think you can do statistics also, like how many token it produces. I think I spent like $3,000 a month in the last month alone, it's like, and so I think about it as like, would I spend that much money? And so unless it's not my money, like, that's fine, but otherwise it's just, I don't know how, and then you start thinking about how much, what is a good allocation of my tokens, Yes, so this is kind of like the last slide. I bundle a bunch of tips, but like if you're coding, telling it to, on top of the file, write what this file owns, because it doesn't read everything. You think it reads, it just poke here and there, and it just assumes that the rest of the file is what it is. But if you do that, it knows exactly where it is in the code base. It's very useful. It keeps it clean too. And when the file becomes too big, I've written my own tool to actually, it's really hard to use for human, but agents are super good at it. And it's like, take this function, put it into that file. And take the comment as well. And you know, like, kind of like a code management solution. I didn't write it myself, you know, it's like, I help, but it's like, okay, parse the AST, do this, do that. Here's the trade-off, use a regex, like, it works. And if you want to have fun and you're doing a lot of, you know, design work, create a team of experts, like a dream team. You know, what I did is I had to ask a question. It's like, I'm going to put everyone, you know, all the most famous programmer, because I know they're in the training data set, you know. So I like unhinged Linus Torvalds, you know, Rich Hickey, all the Carmack and everything. And then I say, hey, how's the dream team? How would they solve this problem? And split each person per agent. When they go and they come back and say, hey, by the way, they disagree. Like, good, give them weapon and let them fight. See who's winning, you know? And that, you should read the transcript after that. It's better than Netflix, I tell you that much. And of course, like, less is more. We need way less. I don't think I really need the frontier model anymore, because it's more like 80% of my work is also like writing files and doing things. But the 20% is like where the real cost is. Like, hey, how should I solve this problem? Give me an idea. I want to see. I have to say that if it's something it hasn't been trained on, it's so painful. Like, it's so painful. I have shouted at the screen more than I can count, you know, because he just doesn't understand. And he starts fighting with me. He's like, no, this is not the way to do. It's like, I'm telling you, it's there, but it just cannot understand. So I'm waiting for AGI, like, please, if they find it, please let me know, because I can come up with a bunch of examples where we're not there yet. Now, don't get me wrong, it's useful. Like, it's very useful. It has made my work much easier. I have a lot of less headache. But when I do, it's like the guy at the beginning with the, you know, the sausage. It's like, oh, why didn't you understand what I mean, you know? It's like, so yeah, thank you very much. If you have any questions.
Have you tried, like, you mentioned in the diagram, I mean, what type of clients have you tried that with, like web clients, desktop clients?
I built a web app. Like, so this was for, you know, internal employee. Yeah, web app mainly. I built my own harness for me, you know, because I was tired. I built it in Go because I don't trust NPM supply chain. And honestly, it's a lot less work than it is. And the thing that took the most work is actually designing the TUI, like the interface. Like, I cannot make something pretty if my life depended on it. So let's be clear. Yes.
What are you using for TUI for Go?
I use a term. I use the bubble tea, something like that.
Bubble,
Yeah.
That's pretty.
Yeah, I mean, relatively. I think, I mean, don't get me wrong. I'm sure it's not the library's problem. You know, it's like, no. And so the trick I find is actually, I need a way to make the model see what I'm doing. So I created the skills that spin up tmux, and tmux has some functionality that can, you know, design. The problem is that you have to tell it the size of the screen, otherwise you put something like this and you think everything okay. But if you put it too big, then, you know, it consumes a lot of tokens. And it's all those things like that. Anything visual, I have found that it's really token consuming, and the reason is that I don't work with visual stuff, like, at all. You should see the web app. It's like, man, take a theme, you know, make it bare HTML, no JavaScript, you know, it's like super, super simple.
You want the Linux system calls, not the program.
I'll take that, yeah, for sure. No, it really depends on what you're working on and how you use it. Like I don't use it much on my personal life. You know, yeah, maybe once I had something, I was lazy and I said, hey, take a picture of that event and add it to my calendar. I was like, oh, that's, you know, I was happy. It's like, hey, useful. But beside that, I don't give it access to my mail. I have my Gmail since 2005. So I have 20 years of filters that are just a single mess. Like, I'm not sure AI can even like go there. But apparently now you can export. I find that you can export your filters and ask it like, hey, you know, clean that up. It's not working really great, but I guess you can refine it, you know. It's more like, oh, you forgot this. You could, if you say make it good, make no mistake, you know, yeah, okay, don't hallucinate, all right, you know.
That's what I told my prompt.
Yeah, exactly. Yeah, so that's the situation. It's still statistics under the hood. I went deep into that rabbit hole because I know that it's just predicting the next token, and everything is memory limited, and that's why the whole world now is going nuts about this to find out that maybe those things are way too expensive and we don't need that much. What I think is that by this time next year, you can run something that is very useful on your laptop, and you'll be fine, you know, for a good chunk of your work, and that will be the progress, I would say. But yeah, this is very much for like if you need customer. If you want cheap tokens, I heard that McDonald's had a chatbot and you can generate your Python from there. And
By the way, cold
yeah,
I don't want a cheeseburger.
yeah, exactly. No, I don't want the cheeseburger. Tell me how to solve, you know, this problem in Python, and then it's.
Their input validation might be slightly faulty.
And that's the point. It's really hard. So I'm really concerned about putting this into the hand of strangers that I don't know, and you know, like it's work. Like it's a lot of work. When they say, yeah, programming in Solve, I'm like, I'm waiting for it. Just show me when I can relax, because for me, we just increase the load on everything else. You know, yeah, we automated a task, but not the job. Do you know what I mean? It's like, yeah, this little part is automated. Congratulations. That was not the bottleneck in the first place. The real value was like, okay, let's see some ideas. Let's organize. Let's brainstorm. That's really, really useful. So that's where I'm at. You know, how is your experience? Because
Can relate.
sorry,
Can relate.
can relate. Yeah. Yeah. Yes.
So RAG is just another tool call.
Kind of, yeah. I'm going to rant about RAG, man, because everybody's trying to sell me. You know, it's information retrieval. It's a field of research. And they've been saying like, oh, it works now. No, to me, it doesn't. I tried everything. You know, I tried embeddings, I tried BM25, I tried trigram, I tried like cosine similarities. I built the thing myself to understand how it works, and nothing really is good because it doesn't tell you when it's not in the data set. You have all you have is a probability, and it's like maybe it's 40% there. And then that doesn't mean anything to you. So it's not like the same. I find that actually, if you don't have a lot of data, retraining a small model would actually be my next exploration, I would say. But everything RAG, like I can see it's not working. I can see they're trying, no, put everything there and everything will be there. I don't see it through. Maybe I'm doing it wrong, you know?
Have you played with segmentation strategies?
Yes, like the chunk size, everything. I tried. You know, you can index some data and then do the embeddings on the index. And you know, it's kind of a joke because it's like, I think it was a few years ago where they said that gzip, the text file, and you know, using Python to gzip your query would give you 80% of the result. But I don't know if you understand. So you take all your markdown, all your information, and you put that into a zip. Then you take your query, you put that into a file, and you zip that. And then you search with the file there in the big zip. Exactly.
Vector search, basically.
Yeah, kind of. 80% result. So, you know, every rug, I feel they try to sell me something, and I don't understand what it is. You know, it's like, I can find this myself, and honestly, it's not that, it hasn't been very good, like where I say, wow, we find this. You know, but apparently, you know, the model is very good at it. Like I find that if I ask a model, look through all that stuff, it has been trained on grep and sed and whatnot tools, and it actually find a little bit because the bits it extract, it can extract meaning from them and make the relationship with my query that is a little bit higher. It's not perfect, but it's way better and faster than setting up a database and, you know, putting the embeddings.
Yeah, vector similarity.
Yeah.
You think almost those kind of agentic memory things might actually work? Where
To
you're
me-
combining like a database with some vectors.
Oh
and
yeah,
go
look.
away into a tool or a
Like-
lab of it.
I feel like sometimes
Do you know this?
the OS.
So caveman, they find out that it's more efficient to talk like a caveman because it uses less token. And actually, I find it, at first it was funny, you know, like, oh, caveman is not dumb, caveman is token efficient. But it just shows that, they show those token save. They don't show you how many times you have to query again to explain what it means because I don't speak caveman. And so, do you understand? It's just all those tools that says like they are token savers. It's a very like narrow way of looking at it because every time he tries, the model see and he doesn't get the context he expects because he hasn't been trained on that particular output, but he's been trained on grep. So, you know, you do a lot less calls, but yeah, that one call, one-to-one call, it's cheaper. But on the global total, the result, yeah, I spend less token by having no tools, no MCP, no nothing. And when I say, hey, you know, go research that on the internet, or like there's a library I want to use, go research that on GitHub, read it, and then I don't give any instruction, just go read it, go learn about it. Because that grounds itself in reality, then I know I can work. And that's where I branch my conversation.
Under Carpati, this came that game prompt, system prompt, he just rejoined Claude.
Oh, Karpati joined, yeah. He joined Anthropic, yeah.
He was the first one to make this idea of
Caveman. I mean, at first it was super funny. I'm not gonna lie, it was hilarious.
It makes sense when you think about the first stage of preprocessing correlation. Now you don't have high correlation numbers, like you don't have many tokens. This like critical phase is way more efficient.
Yeah, that's it. Like, for me, it was really just let the model be the model, and you know, ask it clearly, and that's the best result I have. I'm a lot less frustrated when I make a mistake than when I see it make a stupid thing, and also I watch the prompt, like what it's doing, so I can stop and directly, you know, say, hey, try this or do that. Because at the end, it's just, I just automate a small part of my job, not my job.
So how much of this is just shitty data that no LLM will save? You know,
Which part? Which part?
No, but you're complaining about the memory and the K-man.
Yeah.
That's basically because the data in the world is not good enough.
Oh yeah, of course, it's just
If you had
statistics.
perfect data, it would actually work.
Wow, define perfect data.
Yeah, exactly.
You know, it's like intelligence. Nobody knows what intelligence, or everybody argue. But stupidity, everybody agrees on what it is. And that's really the point. Like, we have to go dumber with those things because it's just like random.
That's why I still have a job.
Good one, yeah.
The last question, when you said retrain a model, you mean
Yeah.
fine-tune? Are the same?
Yeah, fine tune. Of course, retraining the model would be way too costly, but you can fine tune. And nowadays, if you take the small model, I'm talking like, you know, Gemma 300 million parameter, the one that actually Where is it? No, yeah, this is running in the browser, you know. It's not, I'm not using, I'm using the GPU, but the web GPU, web GPU, not WebGL, web GPU. But it's it's the Gemma 4 E2B, so it's 2 million effective parameters, and it's there, right? It's not doing inference, so it's not a decoding token, which is like the costly part, but it's still, you can do a lot with that. And actually, if you fine tune it by saying question answer or query answer, query answer, query answer, and you can use those big models to say generate me a data set for this and retrain it on that, you can do it in less than an hour.
So you would pipeline lots of small models that you can then retrain instead of having that big model that you need to
Well,
retrain.
that's my next experiment. I don't know the result. Maybe you know, I come out soon and say, this didn't work at all, I'm so stupid, you know, it's like, I can fail and be okay with it, but at least like, I just want to understand, because many people, there's so much hype and I don't know what to believe, you know, I don't know, that's the correct answer. I just want to find out, yeah. Thank you.